flawless vanishing of Nancy Guthrie just cracked. The phantom killer left a microscopic DNA betrayer. Now, American forensic experts are racing the clock.
The disappearance of Nancy Guthrie unfolded like a flawless crime. No cameras, no witnesses, no trace left behind. The perpetrator slipped away into the shadows, believing everything had been erased, yet unknowingly abandoned, a silent betrayer. Microscopic fragments of DNA. Now forensic experts stand before a tangled genetic labyrinth where biological traces from multiple individuals are interwoven like an impossibly complex jigsaw puzzle. Can the power of cutting-edge genetic genealogy break through the chaos, turning a single fragile skin cell into undeniable proof, and finally drag the killer into the light? The clock is ticking. Let's unravel this heart-pounding forensic race right now. In an age of relentless technological advancement, can a perfect crime truly exist when every fleeting touch, every drop of sweat, even a single breath has the power to leave behind undeniable biological evidence waiting to be uncovered? We are endlessly drawn into detective stories where the perpetrator coldly calculates every move with precision, determined to erase every last trace from the crime scene. But the truth is, modern forensic science is advancing at a breathtaking pace, turning what was once invisible into undeniable ironclad evidence. Welcome to today's bulletin, where together we will strip away the layers of one of the most intricate mysteries in modern criminal investigation, seen through the powerful lens of genetic analysis technology. It has now been exactly 2 months since Nancy Guthrie vanished without a trace, leaving behind a profound void and a storm of unanswered questions. The scene of the incident lay in a remote, desolate area where security cameras were almost non-existent. This absence of surveillance seemed to draw a perfect black velvet curtain, swallowing every trace of the perpetrator's movements. With no direct witnesses and not a single camera capturing the moment the victim vanished, every hope of the investigators now clings to the tiniest fragments of evidence left behind at the scene. According to the disclosed information, the perpetrator is believed to have remained inside the victim's house for approximately 42 minutes. 42 minutes is a span long enough to carry out countless actions, yet it is also a window of time that exposes any criminal to an immense and ever-growing risk. The longer someone remains at the scene, the greater the risk of leaving behind biological traces becomes. Notably, some theories suggest the intruder may have gripped a flashlight between their teeth while carrying out their actions, a detail that may seem trivial at first glance, yet holds critical importance for the investigation, as saliva carries an immense wealth of genetic information. Furthermore, this individual would almost certainly have come into contact with surrounding surfaces such as the camera or its mount outside the house. Even if gloves were worn, the simple act of removing them or earlier contact with objects using bare hands could still leave behind microscopic skin cells. This is precisely what forensic scientists refer to as touch DNA or transfer DNA. Even the smallest trace of cells can place the key to the perpetrator's identity into investigators' hands. Yet the reality is far harsher and far more unforgiving than what is often portrayed on television. The core issue and the greatest obstacle in the Nancy Guthrie case right now is not the absence of DNA, but the fact that the collected sample exists in an extraordinarily complex and tangled state. Leading experts in genetic genealogy believe that if a complete and viable DNA profile can be obtained, this case could be unraveled in a matter of just a few weeks. But the specimen recovered from the scene is not clean or singular. It is a complex mixture of DNA. This means that on a single surface, such as a doorknob, multiple individuals may have touched it before the scene was secured, resulting in a tangled blend of genetic material from several different people. To make it easier to visualize, analyzing a complex DNA mixture is like trying to assemble a single image from 3 or 4 different jigsaw puzzles that have been chaotically mixed together. If this were merely a simple mixture containing the victim's DNA and that of an unidentified male, scientists could isolate and profile it with relative ease. But in this case, the specimen carries DNA from more than 2 individuals and may even include profiles of people who have no connection to the crime at all. This transforms the case into an extraordinarily difficult puzzle for biological analysts and law enforcement agencies alike. This complexity also hinges heavily on the proportion in which each DNA source is represented within the mixture. If the perpetrator's contribution makes up around 40% or more of the total sample, bioinformatics experts believe advanced algorithms could rapidly separate the genetic data and reconstruct a clear, usable profile. But if that proportion drops too low, for instance, to just 10 or 20%, current technology becomes nearly powerless to resolve it with certainty. Even the most advanced isolation techniques still struggle to determine which fragments belong to the suspect amid a chaotic mix of overlapping genetic information. Before we dive deeper into the secrets of genetic analysis technology and how it could potentially turn the tide, in this case, don't forget to hit the like button and subscribe to the channel so you won't miss any updates on these shocking investigations. Your support is the driving force that motivates our team to continue delivering the most in-depth and high-quality analytical reports. Now let's return to the complex puzzle law enforcement is facing as they process the difficult DNA samples in the Nancy Guthrie case. For decades, law enforcement agencies have relied on traditional STR profiles to cross-check against national criminal databases. This method has proven highly effective in cases where DNA samples are relatively intact, clean, and clearly distinguishable. Crime laboratories have processed millions of mixed DNA samples in assault and homicide investigations using this traditional STR method. However, the limitation of STR analysis is that it cannot deliver a complete genetic picture when confronted with degraded or overly complex samples. This raises a thought-provoking question worth reflecting on. In your view, should there be limits on how much personal genetic information can be collected and analyzed in criminal investigations? Traditional forensic techniques have reached their limits, pushing investigators to turn toward a more revolutionary approach, genetic genealogy combined with SNP profiling. Unlike STR analysis, the SNP method examines hundreds of thousands of markers across the entire human genome, generating an enormous and highly detailed data set. Genetic genealogy is not a new concept, but its use in criminal investigations only truly surged into prominence in 2018. Prior to that, most people, including professionals, saw it mainly as a tool for finding lost relatives or helping adoptees trace their ancestry. Even many professionals were skeptical at the time and dismissed its potential applications in forensic science. The dramatic shift only came when this technology played a pivotal role in unmasking notorious criminals who had managed to hide in the shadows for decades. Scientific attention has since shifted toward refining and enhancing SNP profiling to make it even more powerful and precise. Despite having been applied in law enforcement for less than 8 years, the progress achieved through genetic genealogy has been nothing short of remarkable. From once requiring large, well-preserved samples, such as blood or semen, experts now need only a microscopic trace of DNA, perhaps just a few invisible skin cells left behind by a fleeting touch. This rapid advancement stands as a powerful beacon of hope, reviving cases once believed to have reached a complete dead end. However, hardware development inevitably requires time to keep pace with advancements in data processing software. Methods for extracting SNP profile data from complex mixtures demand highly sophisticated algorithms fundamentally different from the processing approaches used in traditional STR profiling. Currently, computer technology and bioinformatics software are still in a constant race against time, striving to keep up with the demands of real-world applications. In the Nancy Guthrie case, it was precisely this gap in technology for interpreting complex DNA mixtures that led to a significant delay, allowing the search for the suspect to stretch on far longer than expected. But the situation is not entirely bleak, because the pressure generated by high-profile cases often serves as one of the most powerful catalysts for scientific advancement. There have been internal leaks suggesting that researchers are working under intense pressure to accelerate the development of the latest gene-decoding software systems. These technologies were originally scheduled for release at a later stage, but the seriousness of this case and the overwhelming public attention have compelled experts to prioritize and accelerate their development to the highest possible level. Beyond software alone, a new generation of hardware designed specifically to process complex DNA mixtures is also being quietly developed and prepared for deployment. This fusion of advanced hardware and breakthrough algorithms promises the capability to extract and interpret even the faintest, most heavily mixed DNA samples. If successful, it would not only become the key to unlocking the mystery of the victim's disappearance, but also mark a historic turning point in global forensic science, opening the door to solving countless other cold cases. A new strategy is also gradually taking shape in how law enforcement agencies handle major criminal investigations. Instead of treating genetic genealogy as a last resort only when all other leads have gone cold, many agencies are now proactively applying it from the earliest stages of an investigation. This approach aims to optimize time and reduce the risk of the perpetrator committing further crimes. By splitting the collected evidence in two, police can simultaneously develop both traditional DNA profiles and genetic genealogy profiles, building a highly rigorous parallel investigative framework. This strategic shift carries profound significance for crime prevention. If the perpetrator is not present in traditional databases, the investigation can stall, potentially giving them time to seek out another target and continue their criminal behavior. Applying genetic genealogy immediately helps interrupt and potentially stop this cycle of harmful behavior. In many real-world cases, such as the Koberger case, this level of speed and agility has effectively disrupted criminal activity, underscoring that in investigations like these, time is not just money, it is human life. Alongside the complexity of DNA mixtures, another major hurdle investigators face is the question of privacy and the policies governing genetic databases. Although over 50 million people worldwide have now taken DNA tests, the laws and policies of major companies strictly prohibit law enforcement from directly accessing these vast genetic databases. This is a safeguard designed to protect customers' personal information, but it also inadvertently and significantly limits the scope available to investigators. Limiting law enforcement to smaller databases significantly reduces the likelihood of identifying suspects, stretching the time required to solve a case from a matter of days to potentially several years. However, if initial comparisons prove unsuccessful, the FBI may seek a court-issued search warrant compelling major data companies to provide access to their databases. Even so, this remains an exceptionally complex legal process, requiring a delicate balance between the public interest in solving crimes and the data privacy rights of individuals. The involvement of federal agents and the use of search warrants underscore law enforcement's determination to track down the perpetrator no matter how many obstacles stand in their way. Rapid response genetic genealogy teams are now on standby, awaiting the signal from bioinformatics experts to launch a large-scale investigative effort. In that difficult context, locating a possible second crime scene, the place where the victim may have been held or transported, plays a pivotal role in the investigation. This location not only helps reconstruct the victim's movements, but also offers a crucial opportunity to recover higher quality, less contaminated biological samples that could help resolve the case more quickly. A secondary crime scene is often pivotal in solving cold cases, as it can preserve critical undisturbed evidence such as hair blood or fingerprints. In the Nancy Guthrie case, widening the search perimeter became the central strategy for gathering additional physical evidence, providing crucial support to the struggling genetic profiling process. No matter how cunning a perpetrator may be in attempting to erase their tracks, the fundamental principle of forensic science remains unchanged. Every contact leaves a trace. Even the smallest mistake made by the perpetrator can ultimately become the decisive leverage that allows genetic experts to turn the investigation around. Genetic material is remarkably resilient, even in harsh environments. Guided by experience and persistence, investigators painstakingly search vast crime scenes, collecting even the smallest cellular traces from the most unexpected places. Hundreds of samples are then subjected to a rigorous analytical process. Inside the laboratory, technicians carefully process each test tube, working to decode the underlying genetic sequences. This complex process is ultimately decisive, helping to identify the suspect and determine the outcome of the entire investigation. The absence of the suspect's blood at the crime scene is a major disadvantage, as blood typically contains high-quality DNA that enables faster and more reliable analysis. As a result, investigators are forced to rely on fragile traces such as skin cells or sweat, which in turn creates the challenge of analyzing complex DNA mixtures. However, forensic science is constantly evolving and adapting to overcome every challenge. If you found this video helpful, don't forget to follow, turn on notifications, and share it to spread awareness of investigative science, and stay tuned for our next case breakdowns. The Nancy Guthrie case has become a grueling test of the limits of forensic science and modern bioinformatics. The immense pressure of public attention inadvertently created a powerful pull, drawing some of the world's leading experts into a coordinated effort to decode the extraordinarily complex DNA sample. Even though the data extraction process may take months to complete, the use of next-generation genetic analysis software still offers significant hope. This massive collaboration promises to deliver a spectacular breakthrough, not only helping to crack the case once and for all, but also pushing the boundaries of current technology to the limit. Specialized DNA analyzers will create a seismic shift in forensics by successfully decoding complex mixed genetic samples, turning every surface the perpetrator touched into ironclad, damning evidence. However, accurately decoupling each genetic sequence demands immense computing power and rigorous oversight, which is exactly why these high-tech investigations require a significant amount of time. This wait is not a sign of helplessness, but rather a reflection of a rigorous scientific process dedicated to guaranteeing absolute accuracy. This is essentially a silent yet ferocious battle at the molecular level, where justice is ultimately served through the unyielding persistence of science and human ingenuity. The Nancy Guthrie case proves that the perfect crime is now a relic of the past, as every touch leaves behind an undeniable biological trace that cannot be erased. The greatest lesson for the community is unwavering faith in the light of justice, where science relentlessly advances to safeguard human safety and reaffirms that evil will inevitably be exposed. However, this breakthrough also raises a profound challenge on the razor-thin line between societal security and the fundamental right to personal privacy. In your opinion, is investigators accessing private DNA databases to solve crimes a worthy trade-off for privacy, or is it an infringement? Leave a comment to share your views below, and don't forget to subscribe to the channel to catch our next videos.